today. I'm going to be talking at a little bit more of an architectural level about what Connor was just displaying to you. In my role as VP Platform Strategy, a large part of what I do is I look at the other components out there in the ecosystem and try to figure out how best Dataiku can integrate with them. This is a big world. We're a component of it, but we are not the only one. And that's a very big portion of what we look at, both from a storage level, but now also from an LLM level. So let's see how all of that can fit together here. From the last talk, these aren't necessarily the two main takeaways you had to take, but the two main takeaways I took were, one, that LLM-powered applications are really, at least in some ways, a new paradigm. There are new components to these applications that are potentially even more differentiating than the components of the traditional machine learning deployments were from non-predictive applications. There are big differences here, and the deployment strategies and even the architectural tech stack is going to be different for these things than anything we've dealt with before. Secondly, we're understanding that in order to stay ahead of the competition, you're going to be building a lot of these things. They're going to be affecting your organization essentially at every level and across every facet, I guess. So, what is the architecture of these looking like today? What do we think it's going to look like in the future? Let's talk about the components here. As I mentioned just now, there are lots of new LLM-specific components to the architecture of what you're going to be building. We can break this down into 4 layers. We have a data layer, a services layer, a logic layer, and an application layer. At this data layer, we have what we've been dealing with for 10 years. What Dataiku personally, this is what I've had to touch and mess with and help clients fix and understand since I've worked here. Unstructured data, structured data, stuff in a SQL database, PDFs sitting inside of a S3 bucket, JSON blobs, etc. We've been building applications on top of these things for a very long time. But now we have another thing inside this data layer, LLMs. I think of LLMs as primarily data. The parameters, you have trillions of parameters. The size of an LLM deployment is in like the big data zone in that it's dozens of gigabytes potentially. And this component being added to that underlying layer really changes things. How do we access an LLM data layer? Well, we have a service. What's an LLM service? Can somebody name an LLM service that you use? Anthropic, great. Yeah, so Anthropic, OpenAI, Gemini, Azure OpenAI, etc. There's tons out there. There's also the concept of being able to deploy your own service. So I'm deploying something, I'm taking a Hugging Face model and I'm deploying it on my own GPU. But essentially an LLM service is a API-based access layer to an underlying large language model. We also have a iteration on that, which is also LLM specific. So if we have unstructured data, we can now create a retrieval service so that I can ask English language questions of my documents. Of course, for structured data, for decades, we've had data querying services. Thank you, SQL. But we can also consider things like Elasticsearch's querying of large data falling into this bucket as well. And then the final kind of service that an LLM-powered application might leverage are API services. So maybe I want to hit a Google search engine, or maybe I want to look up the weather and have the LLM be able to leverage that capability. Above services is a logic layer. So we hear a lot of talk about agents and tools. Some examples of tools might be a data querying service or might be an API service. These are things that potentially my agent will be able to use to provide responses back to my end users. The other thing that my agent often will need to use, well, always will need to use really, is some type of prompt. We have 2 layers of prompts regularly when we're building out LLM applications. We have a system prompt, and then we have the individual prompt that's coming through when the user types something in, or when you have a data set full of questions or something like that. A system prompt is actually quite similar to what we try to do with fine-tuning, which I'll talk about a little later. But a system prompt, in some way, tells the LLM how to act. You can ask OpenAI to see their system prompt if you're using ChatGPT. And you could see that it's pretty huge, telling that, OK, this is your personality, this is how you can talk, this is how you're expected to respond by default. Individual prompts can override those system prompts, but they are critically a huge component of that logic layer. All of these, LLM services, retrieval services, tools, and prompts, feed into agents. This is what agents are composed of right now, at least the concept of agents. I've actually seen very few fully fledged agents in the wild right now. There's a lot of challenges with combining all these things together, and there's a lot of challenges with creating an agent with a good enough prompt for it to be able to differentiate between these different tools, RAG services, LLM services at the right time. Above that agent is that final layer, the application. How are users working with this complex underlying system? This application can be, well, the simplest one that we all think about is chatbots. But I really believe that LLMs are so much more than chatbots. Chatbots are great. They're very powerful. But the lowest hanging LLM fruit that I see is really more in the application of an intelligent LLM to maybe existing analytics problems. If you have an NLP situation when I'm doing classification, summarization, sentiment analysis, applying LLMs in batch to 70,000 reviewer comments can provide a much more immediate ROI than building out a chatbot that answers questions about your HR services or whatever it might be. Not to say the chatbots aren't very cool and very exciting, but there are low-hanging fruit here with these applications. We shouldn't limit it to just thinking about chatbots. So let's talk architecture now that we have this kind of concept of what the components are. As an enterprise, imagine you want to build a lot of these applications. We just said we saw that box. There's a whole bunch of them. We want to build a ton of them. In that case, it's important not just to think about the architecture of the individual application, but the architecture paradigm of how you're going to build them all. If we think about traditional applications starting, let's say, in the early 90s, what they were being built as was big monolithic blobs, which actually I don't have a problem with. Who here is like a waterfall person versus an agile person? Nobody anymore, but it was a cool concept. That's how they built the Saturn V rocket. That was pretty neat. Sort of. They did blow up a lot of rockets first. But all right, so we build a giant monolithic app. It's huge. It's verticalized. We hope that the decisions we made at the very beginning are the appropriate ones 3 years later at the end. The evolution of this was a services-oriented architecture. SOAs were popular for a while. You used XML, you used web services to have these things talk to each other. You could deal with individual components. You could start swapping things out relatively easily. You could have different teams working on different parts. An even further evolution of classical application architecture was microservices. So here, this is kind of the modern way. You have many small components. They talk to each other with JSON. You can modify those underlying components as long as kind of the contract they have with the overall application remains valid. Everybody pretty much has liked this evolution. The modularization of these aspects has been very useful for allowing more agility versus waterfall development, and has, I think, allowed organizations that are not necessarily originally technology organizations to develop applications successfully inside. So, what's the current paradigm for building LLM-powered applications in the enterprise? Right now, I think if you're starting from scratch, a lot of what you're doing is import LangChain. Google or ask OpenAI to write you some code, chain things together, and then you have a successful POC. Great. And that really is still a pretty monolithic stack. One application works well. Maybe you have one good POC, but then scaling that, I was just talking to an organization earlier today about, all right, we've built some really impressive things, but how do I scale this to hundreds of these things? It's very, very challenging still. There's going to be a lot that need to be built. So let's remember, here's what one application looks like. Great. Let's zoom out and start building more of these. OK, so maybe we start using some of these prompts over here since they work so well over there. This gives a team a great idea for a new agent application, and that's cool. And they're going to use the second agent as a tool, and then all of a sudden we have this big, gigantic, goopy mess that not only is it the slide ugly, but it's difficult and potentially risky to maintain all of these interactive, interconnected components. The truth is that any organization can only maintain so much complexity. Different organizations are capable of different amounts of complexity, but everybody has some threshold where it cannot develop and maintain more applications. We believe that with LLMs right now, this complexity threshold is pretty darn low because it's the first time any of us are doing it, like the last 18 months or so. So if we have a simple graph here, we have the number of LLM-powered applications on the x-axis. The complexity of building and maintaining these things are on the y-axis. And we can see a sort of exponential increase here, partially because the more you have cross-referencing and interactive actions between them. Complexity goes up over time, and it follows, exponential curve. And then we can imagine that we have some starting threshold here, which limits the number of LLM-powered applications that we can build. So how do we raise that complexity threshold so that we can have more applications and more value? By raising that threshold, we have to shift our underlying architecture paradigm. We need to think differently about how we build not just one application, but building all LLM-powered applications inside of our enterprise. So we do have a concept of how we think this should go. And that concept is the LLM Mesh. I've spent the last 2 years working on developing and understanding how this thing needs to evolve. And there's 3 core principles. First, an LLM Mesh should provide an abstraction layer through which LLMs and all of the related services can be accessed. So remember, we had that data layer. We have a service layer. The service layer is where this LLM Mesh provides abstraction. This standardizes the interface for the different services. So whether I'm calling out to a local Hugging Face model, OpenAI, or a database, I have a similar way of working with all of them. I could swap out components as necessary. Second, LLM Mesh provides federated services for control and analysis. The non-deterministic nature of LLMs, the more challenging, there's no R2 score yet for LLMs. We have some concept of LLM as a judge. We have some concept of statistical difference in text responses, but we don't have like an AUC or a confusion matrix yet. This means that control and performance analysis is still quite complex, and having a system in place to perform those operations ends up being critical as you roll out more and more of these. Finally, we need a centralized place for discovery and documentation. Discovery and documentation is really all about identifying and understanding what tools and components are out there, and having a single place for someone like a CIO to come in and review them, ensure that the right ones are being used in the right places. So take it together. That is how you go from that LLM mess we saw earlier to an LLM mesh. First, you establish your catalog and gateway where you have access to all the different objects you're going to be building. Then you create federated services for control and analysis, access, content, PII detection, cost, performance, relevance. And finally, you start building your apps in an efficient, modular, and secure manner. So how is Dataiku helping you do this? First, we are actually still in the process of writing the LLM Mesh guide. Chapter 1 is available now. You can scan that QR code, download it, and start reading it. I think Chapter 2 is actually available now as well. And the full tech guide is going to be available in Q1 of 2025. And you're going to see me again later when I talk about the product roadmap. But Dataiku does offer out-of-the-box LLM Mesh capabilities today. This is in GA. We have the underlying data access layer. We have an app framework through which it's very easy to deploy and maintain visual applications. And in between them, we have guard services, Cost Guard, Safeguard, and Quality Guard that ensure that what you're putting out there is solid and dependable and enterprise grade. Finally, we have a GenAI governance layer that makes sure that you're keeping pace with regulatory requirements, including the EU AI Act. External applications can leverage all of these components for true scale, true reliability, true strength. Thank you all very much.